Hello, good afternoon. Happy genetic programming time. I am looking forward to doing some fun creative coding today, especially since my day job today was all documentation, which is fun with the question mark. And exploration code definitely means we get to pull out the hat. All right, so let's do it. Okay, so where we left off on Thursday last week, it's been a while, is let's see, these genetic algorithms tools, and we are moving on to these genetic operators. So if we pull our lesson up again, let's go to 150. All right, let's jump into it. Albert, hello. How are you doing today? Okay, so genetic operators. These tools will directly impact the genetic material of a new individual. Crossover reproduction. I guess we can summarize what we have so far. So previously, we have, in this specific genetic algorithm, Esitsu, hello, how are you? In this specific problem that we're solving using genetic algorithms, we're trying to guess a password. Now, the password has been implemented in the worst possible secure way. It's stored in plain text, and we know the length of the password, and we know what we know the character set of the password. So obviously this would be easier to break using more traditional methods, but we're doing this way first. So step one, we have this create a chromosome, which just literally creates a string of the same size. And it's of random letters. That's our starting point. So we're creating a bunch of entities. Then we get the score. So we find out how close we are. Dota, hello, your feature works? Awesome. Congratulations. That always feels really good. Congratulations, congratulations. Especially when you started in like January. If you waited for what, like 2.5 more weeks, then you could say that it was, I started this in January and I'm finished. Like it was only a couple days. Oh, July. Okay, you have to convince them to wait for like 6 more months. You want it within the year? Well, no, here's the thing is you don't tell them that it was a year late. You just say, yeah, this was requested in, earlier in January. And then you hope that they don't follow up with any follow-up questions like which year. That would obviously be the problem. It's rude to figure out how long it took. Exactly. See, you get it. All right, so we have we get the score. So really this is how many letters are the correct letters in the correct positions. So obviously if we're starting with random, there is a chance, but a very small chance, that there will be correct. Any of them will be correct. And so most likely we'll start with a very low score. Oh, you're trying to learn C right now. Awesome. Let us know how that's going. It's going terribly well. I'm sorry about that. In selection, we're sorting them by their score. So we're saying like, okay, let's say we have 100 chromosomes in our list. We are saying, okay, take the top X%, and they get to survive. Congratulations. Also take just a random percentage of the remaining ones. And the reasons for that is because we don't want to overfit in a certain direction. So the other ones, basically the idea is like, hey, you had a really good idea. That was a really good way to do it. You sucked at it, but you had a good idea. Let's go ahead and keep those genes in. We don't know if they had a good idea or not, so we're just going to choose them at random and hope that it was a good idea. And that's it. That's what we've got so far. Rude because it makes people uncomfortable, but sometimes you want to make people uncomfortable. The also, hello Tea Kettle Drone. How are you doing today? Living in the uncomfortable zone is like kind of important in my mind, but I try not to force people into it because that doesn't go too well. All right, so that's what we got. You should see my spaghetti code and see. It's okay. I've done plenty of spaghetti code myself. Although I haven't written in C in a long time, so I'm certain mine would be even worse than yours. How do I extract the interface? C programmer. By interface you mean like the file handler? The interface to the hardware? The header file? Yeah, things like that. Your mega header file, the one header file to rule them all that you just import into every project. That has like 1,000 lines of all the libraries. Okay, so here we go. Genetic operators. These tools will directly impact the genetic material of a new individual. Crossover reproduction. We now need to fill our population with a new generation. In order to create this generation, we will make individuals reproduce. During this step, the parents will be exchanging their genetic material to produce a child. Genetic recombination. Now, if I understand correctly, our entities only have a single chromosome. So it's gonna be a very simple crossover, I think. Albert, you're heading to bed. Well, have a good night. Thanks for stopping by to say hi. Oh, well, this will probably be good, Dota, because like learning to write alternate ideologies, methodologies, paradigms of coding helps out a lot. Like it helps the skills. So I'm always a fan of being forced to learn those. Oh no, I'm gonna build the OP yourself. Or you could go that route. But oftentimes, even when you go that route, you'll probably come out learning some kind of life lesson from it. I mean, just don't recreate all of C++, please. Okay, so now, so we have like two parents, so red and blue, and then become a little bit of red. So, oh, and there's this crossover point. So they're just basically snipping this off and then switching over. Interesting. A solution is to take each parent 50% of their genetic material, making a crossover in the middle of the chromosome. For instance, which is not what this shows. For instance, the parents are A, B, C, D, E, F, G, H, and 1, 2, 3, 4, 5, 6, 7. The child will be A, B, C, D, 5, 6, 7, 8. There is no change in the genes' places. There are other types of crossovers. One can take 70% of the genetic material. That's what this one looks like, or 30%. Or we can do the crossover on multiple locations. Okay, so basically, this is where a lot of changes could be made to customize this and make it like really good. Is this for Pod Racer, or is this for something completely new? This is for, well, okay. I'm using Podracer as the excuse for this. Because obviously we don't really need to do evolutionary coding for Podracer, but I've always wanted to do this, like pretty much since I started coding. So therefore, an opportunity comes up where it like matches a theme, we're totally doing it. Let's see. Edmondson, hello, how are you doing today? Sorry for butchering your username. Am I using Code Forces? Code Forces. No, the website I found was linked to from Coding Game, and it's this tech.io. So that's what I've been using. I don't really know any good websites that sort of like explain these things in simple terms, and so far this one has been pretty good. Pretty good as in like simple. Okay, so coding time. We want to implement the crossover function, so select half the parent genetic. Okay, so we're going to do a 50-50 merge. And then obviously this could be a different thing altogether. So if I wanted to take half of parent 1 plus half of parent 2, I think what we can do is say, can I do a new gene? Is there like a split, or do I have to loop? I can do something like child equals, I mean, what if I do parent 1, I copy it, and then I take, can I do something like this? Child of, let's get the length. So if I do that, ooh, yeah, so I probably don't want that. I want this to be, move that up there. We're just going to say, give me parent 1 of 0 through length. And then I want to take child like plus equals. Will that work? Parent 2 length. Oh, wait, it's like that. It's colon. No editor makes it harder. It does make it harder. Yeah. Okay, and then we're returning child. And I'm having to remember, like vaguely remember like my Python, because it's been so long since I've used it. Okay, well that apparently didn't work because I got, okay, so parent 1, so this was, okay, so this is identical to its parents. So now I think I can do like a print line, print of child, print of like length. Can I do prints of multiple things? Can I do like print of parent 1, parent 2? Will that work? It does. Okay, so it's supposed to be like A, B, B, B. Okay. Oh, you think he'd ask? Oh well, if he shows up, or if anybody knows Python, like better than me, because it's been way too long since I've used it. So I'm just going, a lot of it just sort of like, what was it again? But I don't necessarily want to bother anybody for this. So I'm perfectly happy muddling through too. Oh yeah, if you don't bother somebody if they're working and like trying to get stuff in, like that, their work where like they're actually providing value for like a customer supposedly, that's way more important than me learning this and getting a little bit faster. Okay, so this was not the right way to do it. Now I could probably, can I mutate our string is mutatable. Like, can I just create, get the length of that? Could I just say, I want child equals parent one. I could just loop through the parent, right? So you can basically just do whatever you want with Python memory. Okay, so I can maybe set individual characters in line because YOLO. So if I do like a for index in, so I want range from length divided by 2 through oh, it's not length divided by 2. Length divided by 2 through length. Then you can do a print index to make sure I'm on the right path. It did not like that. Oh, it doesn't like the colon? I thought that's how you can do ranges. Can I do, is it ... Oh, is it comma? Float cannot be interpreted as an integer. Was the length not 1, 2, 3, 4, 5, 6, 7, 8? It is. Half that is 4. Come on. Okay, can I just do int this? Okay, so you have, okay, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15. Okay, so I think this is gonna work. So for this, then we're just gonna say child of position index is equal to parent 2, parent 2 like that? Parent 2 index. Oh, I was really hoping, okay, so stir object cannot do that. I can't do that. This is Python, yeah. Yeah, so they have something that's not mutatable. Okay, so how do I want to do this? I could, oh, I can just put them into an array, right? I can just split this. Is it split like this, or is it going to be split and then hand parent one? Empty separator. I wanted every character. Yeah, I mean, usually you don't need to worry about it too much. And oftentimes the type of programming you're doing in Python, you won't really care that much about speed type stuff. Okay, empty separator. So I want to split. So Python, I want to, I guess like, actually the best way would be, instead of split, can I take a range? Can I like combine, what is that? Concat strings? If not, we'll turn it into an array. Take two separate strings and combine them together with a plus operator. Okay, so maybe that will work. The plus operator. So child, okay, so equals parent1 0 through length divided by 2 int that plus parent2, and this will be, let's just do this as half. I keep on wanting to add in semicolons. Okay, and then this will be half length to the end. How about you? Cool. Okay, that's a nice neat way of doing it. Okay, so you're happy. All right, so this is doing our crossover. All right, now it's time for Rust code. Okay, so should crossover 2 chromosomes. All right, so we know there's a couple things that we need to handle. So we want, I guess, like should crossover 2 chromosomes. Maybe they have like multiple asserts in this one, or we can do the happy case first, maybe. So if I have like chromosome 1, great chromosome of 8. Oh, actually, we want to do this probably like that, just like what they did. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 2 of you. I want to run the crossover, which means I need a function for it. Okay, so this is gonna be crossover. I guess we'll take chromosome 1. Okay, how do I want to do this in Rust? I want to take the first half of it. I can Can I actually get a range of one? I don't think I can, right? Like, can I do the same trick? I guess I know I'm thinking in here, can I just grab the first half of this one? Like, is there something for me to say, like, let mute child equals chromosome 1. Yes, I can slice. Slice. Not splice. Not cares. I can't just do this, right? Like, I don't think that works. It kind of works. Oh, right. I need the and. Okay, that kind of works. So if I do that, then in this case, we can say our child is going to be, let's format this. We're going to get the first one and then the second one immediately. We'll just return this straight up. Two, okay, so I need the length. That one just was fine. I don't have to int that. So then go from 0 to length. Go from length. No. Length until the end. I think that works. And like that, right? Yeah, okay. So in reference of you basically passing memory references to the function headers and grabbing the values out inside the function. Yeah. Okay, and then format converts it to a string. No errors. So let's go over here to the right and see if this passes. Should cross over to chromosomes. Okay. Excellent. Now, wait, we didn't call it, did we? Okay, so let's get a result equals, we want crossover chromosome 1, chromosome 2, our expected result is 1 2 3 4 1 2 3 4. Okay, it's still good. Oh yeah, that would have worked too. I you know what? It's just not in my it's not what I'm Oh no, that doesn't work. It's not this one. It's that one. It's not what I usually think of when I'm coding. It takes me a while before it like starts to internalize and I start to add it in a lot. Now, okay, so it should cross over to chromosomes. Like we get the right result. Yeah, so we're just gonna dereference that at that point to get the string out. I could have sliced that one too, and that would have worked. Okay, so you're happy. Let's see. You are comparing pointers there, are you? Am I? I might. Let's find out. If I change you to like an A there, that fails. So it works. Okay. Rust does not compare pointers unless you explicitly get a pointer, which is nice. Oh, this just uses the partial equal implementation. Oh yeah, so it's partial equal implementation of stir to a string, which they've implemented, and by they I mean like the actual language itself, for us behind the scenes. Okay, so that's crossover. Okay, so we are created crossover function. Oh, you're worried that AAAABBB will reference the same memory address as the result? That is the only case if I declare two variables separately to be the same string. It shouldn't be, because we should have two pieces of memory that just happen to have the same value in them. But when I create the same thing, it's not going to automatically like point to the other thing and say, hey, you're exactly the same. Let's go ahead and reference that. So I didn't get a stir from the result string. I believe they'll be different. Yeah. But the values behind the scenes are going to be the same. And generally speaking, when you want to compare things, you want to compare by value, not by pointer. Is there a way for us to like see the pointers? I've not really done much pointer stuff. But in the meantime, let's continue on. Mutation. In order to create new genetic material, some individuals will mutate. A gene will randomly be mutated. Okay, so just one character difference. Is that it? Okay, so we have a get letter function. So I want to just choose one of the things and change it. It doesn't say which one we should do. Okay, so we should do random index. So our index is going to be what? Random. Can I just do like random? Length of the chromosome, and then we'll do chrome of index is now equal to get letter, return chrome. Object is not callable. What is it? It's random dot something. Random dot random. Oh, it's not random.random. It's random dot something. So that's random dot choice. I want random dot random dot. With math, wait, math random is. That's JavaScript, right? All right, hold on. So this is Python. So yeah, let's full screen this. I want Python 3. Import random. So I want random dot. Oh, is it going to be rand range or something like that? Or is it still going to be choice where I just hand it like 0 dot dot like 8? No, it's not. Not that. How about random dot rand range? So 0, 8. That's it. And that's not inclusive. Okay. So random dot rand range, 0 through the length of Chrome, and then what? Stir object does not. Oh, right. We can't do the assignment thing. Okay. If I can't do the assignment thing, do I have to split it out into a vector? Oh, Vampire, hello. How are you doing today? I mean, it might be the underlying library, but they named it random instead of math.random, which is fun. Okay, so I need to split this out first, don't I? Before I can like update it. So I split it out, update one of the things, and then go. So can I just do something like Chrome? There's examples of methods in C++, C that span languages. Nice. Okay, so what if I do Chrome dot equals Chrome? Ooh, but we learned that Chrome split isn't what we think it is. I mean, I could do that. That would be really silly to do, right? I could just get. Okay, what if I do the same trick as before? What if we say return, we want a new thing, right? Return Chrome of oh, we need a random index. Let's do random 0 through the length Chrome. And so I want this to be 0 through index -1 plus then a random letter plus whatever the remainder is from index to the end. Yeah. Okay. That, I don't like it. Okay, mutation. Okay, so should mutate chromosome? Okay, so if we have something like 1, 2, let's see what. 1, 2, 3, 4, 5, 6. Sure, you could just be 6. We don't. Doesn't really matter. I don't know what the expected result is, so I just want it to be off by 1 error. I want the count of A's. Can I do... I could substring the A's, right? Or I could find... No, not find. It's, like... A count, like, A count equals chromosome. I mean, really what I want is like, is there a way for me to like count how many A's there are? Without looping through it. I mean, I could iter. Oh, you're not helpful at all. Can I iter? There is no iter on a stir. Now matches. Can I matches like A as the pattern and then get the count? And then we'll just assert. We'll assert equal that A count is the same as, so what, this was 6. So let's just say we're looking for 5 A's. All right, sorry about that. I've let's see. So let's try running this as a test. Left is 6. Okay, left is 6, right is 5. So this might work. So I just count the number of A's in here. So then I want this to be 5 because I want something to be different. So you're gonna want a mutate now. Okay, so I want to take one of these and just change it, just ever so slightly. So how do I want to do this? Now I have this as a stir. I could turn this into a mutable string. And then I think we can just update one piece of it, right? Because it's a string, not a stir. Like, could I do something like this? So can I to owned that and then say chromosome of like position 3 equals M? Cannot be indexed by integer. So no, I can't do that. Iter over the, yeah. I was hoping that like, hey, I said you're mutable. Okay, so I think I have to get, okay, so if I get an iter, then I can skip n number of them. So we can do, so I want the number to skip to be equal to RNG gen within a range. The range is going to be 0 through the end minus 2. Let's see, I want the length of minus 2, I think, right? So that way I could be updating the last one. Leostera, hello. How are you doing today? You see Dota 2, you press follow? Wait, did I have Dota 2 somewhere? I've never played Dota 2. Have you ever seen the handbook of neuroevolution in Erlang? No, I have not. I'm very new to neuroevolution stuff. Oh, you see, okay. You see Dota, the chatter, not Dota, the game. I keep, when, my brain today. I need more caffeine, apparently. Okay, so I know it's very easy to confuse me when I'm learning too. Okay, so I create my skip. Let's now create an iterator through this. We'll skip a certain amount. What do we want to do? I can turn this into an array, like a vector. We can either do a vector and an array. No, we can collect this at the end. So we can get we can just get an iterator over this. So let's I'm able to do this all in one go now. Let's take our chromosome. Let's get an iter. We can do an into iterator. Oh, I can't do an iterator from this, so I have to turn it into a string. Then we're going to do an into. Oh, can I not do an into iterator like this? I can't do iterators off of strings. Oh, I can char. No, chars. Chars. There it is. Okay, so I chars. That gives me an iterator. Oh, I could also iterate over a slice. I can get a slice of it. That would work too. Okay, so I get the chars, and then I want to skip the skip amount. And then I want to, let's see. Can I replace one of these things instead of doing mine? Like instead of doing the next thing? Or you know what? We could just do the same trick that we did in Python with the slices. That would work. The slices should be better. So I get my index of like what I want to do here, and then I want to turn a format. Okay, so we're gonna want the beginning part, the random character, and then the end part. So beginning part, that's gonna be chromosome of 0 through index. Then I want a random. Do we have like a random? No, I want a random character. Is there like a sample char? I don't want a string. I want a. Oh, how come the chromosome is a string, by the way? The thing we're going through, the tutorial that we're going through is having us guess a password, and the chromosome is apparently the password. So that's it. That's why. Oh right, Jen, can I just Jen? Oh, it's RNG dot Jen a care. There we go. Okay, so put you in here. Then we have our random character, and then chromosome index through the end. Did that go to the end? No, that doesn't go. That goes until infinity, right? Like this won't work. Okay, several problems. Size cannot be known. Ooh, yeah. So we're gonna have to do the chromosome of length. Go into there. Ooh, okay. Yeah, I need. Keep on forgetting. I need the at. Okay. So, oh, actually, I want to keep that assertion in here. So we want our result to equal to mutate our chromosome, which apparently I misspell. I've been misspelling chromosome. That's cool. Chromosome. There we go. Okay, so chromosome. We get that. We'll do our expected. It's going to be equal to 5. Okay, so get our. Wait a second. Okay, so we get our A count. So I want. So our A count of this is going to be results. Let's call this mutated. Matches A count. Okay, so expected equals 5. Okay, so our A count and expected. There. Left is 6. It didn't do it. Right is 5. Uh-oh. It goes to the end. Thank you, Leostera, for the follow. I mean, I guess we could turn it into a vector. I'm just doing it exactly like the tutorial is showing. So we're staying like low on the Bloom's taxonomy right now. And then we can start going up higher once we have things working as expected. Okay. That didn't do it. What we can do is we can assert equal also that a chromosome is there assert not equal? Ooh, assert not equal. So chromosome is not equal to 1, 2, 3, 4, 5, 6. That. So this should tell us, yeah, okay, they're not supposed to be equal, and they exactly are. So that did not work. I apparently don't. Yeah, mutate is what we're calling this. Okay, so I'm returning this. Am I missing one? Or am I not going into the end? It's like go until the character. Okay, so give me a range between that and chromosome length. Go that into the index. Put the random character in. Go index into the end. Oh, I need to go halfway through. Oh. No, wait. No, this is right. Go that until, like, if it's halfway through, that goes halfway through. Then we put that in there. And I saved it, right? Okay, stop locking. Thank you. Yeah, okay, so chromosome, mutate the chromosome. The mutated, okay, so then I count that. Chromosome should not match the original thing. Nope, I wanted to do save like that. There you go. What did I do wrong with this? Do I need to do more than -2? This should make sure that it's the last one is still available, right? So we get the slice of this one, and then the slice of this one. That should finish it out. We want to use some min-max there to make sure the range doesn't go negative. Can it possibly go negative? Because I'm getting the range of like the... Oh, yeah, you're right. Yeah, I could say like... Yeah, I might want to... Like max 0, if it's, and I guess we could do this. Saturating sub? What? I don't think it's max like that, right? It's something that I do around it, like max 1. Oh yeah, max 0. So it can't go below that. So if it oh no, wait, returns the maximum of 2 values. No, I don't want max, I want min. If it's below 0, return 0. Wait, really? That's how that works? Comparison returns the minimum of 2 values. Oh, weird. Wait a second. Oh, that's what you were trying to say. Saturating sub. Oh, okay. I had not heard of this one before. Saturating enter subtraction, compute self minus right hand side. Saturating is the numeric balance instead of overflowing. Okay, that's nice. Okay, so hold on. Let's undo this. Go back to that. Okay, so I want to do length saturating sub 2. Like that. There, I think that'll work. But I don't know if that's the problem. That wasn't the problem. We tried, yeah. So, I mean, we may have we fixed a potential problem for sure. Absolutely. But it wasn't the problem that we had actively right now. So that's always, it's always fun when we do that, right? It's like, okay, well, we fixed a bug. Unfortunately, the original bug remains. Yay. Why isn't random care changing? That's interesting, right? Like, why isn't that? What I am trying to do now, okay, this would be interesting to see. Let's put in a debug. What is our index? I'm curious for this. And then we have to cargo test with the no capture thing. Our index is 1, for example, this time through. So if we think index is 1, that should have been, this A should have been changed to something else. Okay. If we come back to here, index is 1, and let's also take a look at the random character. Why did you, oh no. It crashed? Okay, no, it didn't crash. It just took a little while. Our random character, oh. 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 I don't want it to be any actual random character. I want that to be an alphanumeric random character. Not, oh, okay. Kublai, can I pass a mute ref and make you 3 meters tall? Yeah, sure. Just send it to my PO box and I'll put in the appropriate like request and then send it back. I'm sure that'll work. Yep, Unicode. That's not what we want. So I need alphanumeric. Gen int 8. Will that work? You mean I8? Okay, that will create a number. Okay, so if we do that, our random character is now okay. What? Yeah, I don't want to do that. I think I want an actual alphanumeric character. Skimus, hello. How are you doing today? Oh, we could turn it into an alphanumeric character, but I think I wanted to use that sample thing that we did before. Which if we went up here, we could see that we just did the sample string. Let's just do that again. Where's my mutate? There. Nope. That one. So if I put I don't need you anymore. Leave that. Random character goes in there. We have a size of 1. All test pass. No, wait, not passing. Failed. Oh, still the same. Okay, why didn't that work? Well, that's too bad. I was hoping that that would give me a random character like that. Okay, so fine. We'll do our debug. Random character. That was alphanumeric, so that should give me the thing I was expecting. Oh, I want to own you. Okay, you are H. Wait, no, you're. So running 5 tests. Where's my debug? Is that it? H? Hold on. Let's put a. Oh. Random character. Is Is that not giving me what I expected to be giving me? I'm confused about that now. It's L in this case? Where? Oh, there's the L. Okay, I missed it over and I left. Oh, and the one, do I need to trim it? Oh, the parallel execution of tests is printing out of order. Okay, that makes sense. Right, because the tests do run in, they'll run in parallel, which everything is happening all together in here, so that should be fine. I'm not relying upon other tests in this case. So the L should go in here. We're also looking at, let's see, random character and index. Okay, so we have our random character is W, and then we have our index. And I want that W to go in here. The final format of the stream is not changing. That's correct. So what I was trying to do is basically say, okay, take the first part of the string. So is there an easier way for me to do this than like just looping through? And I feel like there has to be a better way. Well, I guess you know what I could do is I could split this. I could split the chromosome into a vector and then change one of them of characters, which should be fine. So let's try that. That'll be the next experiment. So can we see the test code? Yeah. Here's our test code. Oh, we tried that Leostera, but Rust won't let us change the character. Unless, can I dereference into it? I mean, that would be yeah, that would have done it. So that's a good thing. Utsby, hello, how are you doing today? I was testing input. Fun times. Okay, so that part's working now. The 6 and 5 isn't working. So I was counting the A's, and the assumption is that it's not going to create an A, a lowercase a. Index was 3, and it was, the new character was T. It should have put that in there, and it didn't. So I'm expecting to count, okay, so I'm counting the mutated, I'm matching the number of A's that got in here, and then my expected is, I still have 5 A's. And so my count was left on a 6. So that would be this A count. So mutated matching, so that got all 6 of these in here, and I wanted 5. I'm changing the length of the string while mutating. Oh, yeah, that would not be. Second use of index needs to be +1. Oh. Ooh, yeah, okay, that's not good. Probably doing this like the way wrong way. Can I just like reach into a string if I have it mutable, can I like dereference it to get the exact memory location and then change that? Can I do that? Because that would be the easiest thing. I was thinking maybe the other easiest thing to do would be to just turn this into a vector and then change the one thing. Like that would be a lot more readable. And I kind of like that idea a little bit more. Yeah, we could do the map, but I don't want to like have to do, like if I'm going to map through something, I might as well just turn it into a vector anyways. So yeah, let's just do a split. I think that'll be easier to deal with. So what if I do this? We'll let our characters have a chromosome. We'll split you at every single thing. We'll make you mutable. Can I now do characters of position? Leostera, thanks for hanging out and have a good rest of your day. Can I do index, which I just want this to be -1 now. This is not inclusive, so I don't need to do a subtraction at all. That equals the random character. And then return characters. Is it join or is it collect? It's collect. Okay, you're upset. Oh, this literal can't be empty. Split at a pattern, everything. Oh, I can cares and then collect it into a vector. Yeah, I was hoping like maybe I can iterate into that, but no, fine. Let's get cares and then immediately collect it into a vec of care. Mismatch types, expected care, found a string. Oh, because random character is a string. Yeah, I need you to be... Is there an as care? Can I get the first one? Copy into indexed. Isn't there a way to get like the first character? Imazdren, hello. How are you doing today? I'm gonna ask Stir. I don't think that'll help. Oh yeah, we could do that. Yeah, that's probably a better idea. What was it? Alphanumeric sample care, right? Sample care. Was it sample care? Let me go up and find what it was. Oh, RNG sample. Ah, where's my code? Oh, but I don't want it to be a character. I need it to be an alphanumeric character. So... Oh, RNG sample alphanumeric. Oh, I forgot. I missed that. So I give it the alphanumeric distribution as a char. Okay, I see. So then this becomes random character. We collect this. Vecchar is not an... Oh, yeah. So hold on. Now, We have a vec of chars, and I want to turn this back into a string. Now, oh yeah, I can just join. And a separator of nothing. Method joined Vix, but it's trade. Oh, wait, what? This is way over your head. Real challenge for you to stat focus for 10 minutes in this. Oh, to stay focused? Oh, sorry about that. Oh, string from UTF-8 be unwrap. Jepfo, hello. How are you doing today? I have characters. Will that actually do that? We can try it. I don't know if that will actually force the type though, because if I do something like as char like that, it's going to say, hey, this is a U8, so I still need to convert it into the type. So I'm getting a U8 here, so I have to do something. Think you should do let random, let's see. Okay, so join. The method join exists for. Okay, so hold on. It's so I have a vec of char. I want to turn this into a string. Now, 2 vec? No, that doesn't seem right. Join flattens a slide single output. Now it knows that I'm returning a string. So if I do join with that, you're upset because the method join exists for vec char, but its trait bounds were not satisfied. The following trait bounds were not satisfied. Join char of join. Into iterator collect string. We could potentially do that. Let's try that. So if I just into iterator collect, yeah, okay, that makes it happy. So we turn it into an iterator, and then we immediately collect the iterator. It knows it's turning into a string, so it just collects into that. We have our tests. Let's come over here and run them again. And everything's passing. Excellent. Okay, okay. So that is mutate. One item in them is passing. Thanks, everybody. Okay. We should probably clean up some of these warnings. Okay, no more warnings, which means that we can come over here and we're going to do a... All right, so this is mutating chromosome. All right, back to the tutorial. Okay, next. So that was all this preparation stuff. We haven't actually done the real stuff yet. Algorithm. Okay, algorithm overview. So step 1, create the base population. We create a random initial population. Kind of like scroll down on this side? No? Oh, that's... Oh, there we go. Create the base population. We can create a random initial population. Each individual is defined by its genetic material. We create a new individual with the previously declared chromosome size function. Okay, so that works. We can create just a whole bunch of them. And then we have that over here. So, oh, so we need to create a population now. Oh, link for the tutorial? Absolutely. I mean, this will take you to where I'm currently at it, and then you can probably go back until you find it. There you go. Yeah, okay, so you can go back this way. So, create population. So, the first thing we're going to do, and I would assume you're going to return the population, right? So it's going to be, in this case, an array of these. So let's see, create population size, chromosome size. So if we do, I want Chrome to be an empty array. And then we want to just like for whatever in range hop size. Then we do chrom plus equals, create chromosome with the chrom size. Okay. And then return. Oh, this should be population. Okay, so that would be 1. We're going to find out if we're right soon. I kind of felt like they got tired of like making one little thing at a time, and they're like, okay, no, we're just going to do it all at once now. You're going to find out whether or not you're correct on any of the steps at the end of the rest of the steps. So it kind of feels a little bit like do the rest of the owl. Evaluation. Each individual is scored on its fitting to the problem. Right, so we have that. So here's our algorithm. So our chromosome size and input. So wait, this is like coming in from the command line. So we call it and we just tell it how many we're going to have. Our population size is just unknown. Do we just make this up? Okay, I guess we'll go down to this one. So to do, implement the reproduction. So use the selection population function, create an exercise 2. So we now have a new population. So we selected the top 30% plus the just 20% random. Reproduction, as long as we need individuals in the population, fill it with children. Okay, so okay, so then we take, don't we need to like create new ones? Oh no, we create children. That's what it is. Okay, so children, we do that. Well length children is less than question mark question mark. So this is where our population size comes in. So I need the population size up here before hopefully it doesn't get mutates in there. So this will be length. Length is population. Crossover. We have parent 1 is going to be randomly selected. Oh, interesting. So we're going to do what is that called? Random. We looked at this. It was, let's say, and I want random. Was it sample? Random sample test. Oh no, that's not right. Choice. That's what it was. Choice. If I spelled it correctly. And then test. No, okay, no. So that was still. Is it okay if parents are there's multiple parents of the same one? Or do I want to remove it? I feel like there was one that removed it from the range. Or what removed it from the array. I thought it was sample, but multiple will have to be allowed. So this is where the tutorial is not that great because it doesn't tell me, like, is that okay? Yeah, I only have 50%, but like of that 50%, now there's like, you know, one parent from that survived. What if that one parent is like a parent 3 times? Is that okay? Or is that not okay? I don't know. Or do I want to like just evenly grab out? Maybe it's okay and maybe it's not. So if it's random.choice and we don't care, then I can just do I want this from population. So we're going to do pop. And then that's going to be exactly the same thing twice. What? I can't. Okay, fine. It didn't let me paste. They removed paste. Okay, so then we'd use the crossover. You're right. I do want it on selection. Yeah, but otherwise it would be like, hey, we're selecting the top 50, the top best of you, and who cares about the rest? Okay. I guess we have to do this way, don't we? Right? Because we got rid of half of our population, but we need to build back up to our population again. And so every parent is going to have to be at least once. Yeah, okay, that makes sense. Okay, I didn't. So each selected individual, like chromosome, yeah, each selected individual will have to parent at least one child. That's actually not true. That's not true at all, because they randomly might be not going over, but like it's okay. I guess what it is like some individuals will parent multiple children, and that is expected. Okay. So use a crossover. So then we mutate them. No, crossover. The crossover is have a child. Okay, so crossover is combine the genes. Then we mutate the child. Then we add the children to our list of children. Okay, and then continue doing our loop until we have enough children. Then we return select plus the children. Right, so we're keeping the survivors and we're just getting new children to add into our population. Okay, so then we have our algorithm. Okay, so we have our chromosome size is coming from our input. Our population size is question mark, question mark. Does this say here? Evaluate each individual's squares is done by beginning to section. Selecting each individual has a chance to be retained proportionally to the way it fits the problem. Oh, interesting. Probability from 0.1 to 1%, each child have a chance to have a randomly modified gene, which is not true. I think the one they had us do was like 100% of the time it had a random gene. So this doesn't feel like it's doing that. So population size, I guess we're just going to set this to be like 100 to begin with, because we don't know. And so it's just going to be like, okay, we're going to have 100 individuals, and then we'll tweak it from there. Create the base population. Okay, so we do that. We have our answers. While a solution has not been found, create the next generation. So our population is, we want to create the population, right? Oh, here's the crop. Oh, we want to use the generate. We want the generation population. Display the average scores. Okay, so then we print out these. And then once it has a solution, okay, print the solution. Display of the population, watch it improve. Check if a solution has been found for append Chrome. We have, okay, so we have answer. Okay, so if the answer, if is answer Chrome, answer is append. Oh, so like we could have multiple of it. So print the solution. Can I do multiple things in here? I can't remember. I think I asked that before and I forgot. So then I want answers 1? Like, we could potentially have multiple answers. Logain, hello. How are you doing today? I mean, I kind of want to just say, like, hey, let's just take a look at the answers. Ooh. How do I run this? Oh, run. I guess this might take a while because it will take... It's having to go through multiple generations to see if it can find it. And I have no idea what they're testing it with, because they could test it with like a really long sentence. I did not provide a result in due time. Will you show me the output at all? No? Oh. Well, that's unfortunate. Display the average score of the population. Oh, so this one doesn't have a to-do. So I want to... Can I do that? Will you show me how close you're getting? You did all this stuff in Java, skipping to Python. You don't know, it is funny. Length of children is less than children population minus select length, otherwise out of memory. Okay, hold on. Let's... Yeah, we might have to just skip this step of like testing it in Python and go straight to Rust with this, because yeah, it's like, I thought the first part of it was perfectly fine. It was like writing us through and like keeping us at low level, and now it's like, okay, now do more stuff. And it's like, okay, you didn't step me up the Bloom's taxonomy, so it's like, okay, that's great. But we'll figure it out. I find that a lot of online tutorials don't do that really well. So okay, so length of our children is less than length population is length. Wait, which one is this one? Or yeah, this one. Well, length of children is less than length of population minus length select, otherwise out of memory. Okay, well, I think unfortunately we're gonna have to do this on our own now. So that's gonna be fun. Yeah, line 27. Yeah, because they're adding children to the select in the return. Oh, you're right. Select plus the children. Yeah, so I need to do, well, the length of the children is less than the length of population minus the select, right? Yeah. So we do that minus, and this should still be positive. So select there. I don't think this is going to give me any information unless the out of memory was causing it to crash, and therefore that's why it wasn't giving me. Ooh. Now we're getting better information. I think it's supposed to be going up to 1.0, I believe. And it's not even, it feels like it's staying still. Use a smaller population. Yeah, we could do that. You got the best results with 10. Interesting. Okay, let's try that. 10. Output limit exceeded. Okay, so I can't do too much of that. Oh, I probably want to display the average score of the population. Okay, so I need to... No, but this should be that. So it's the average score of each population. I feel like this isn't improving, though. It feels very the same. And I'm guessing they want, like, the first one. But... I think we have to switch over and just do this entire thing ourselves. That way we can, like, watch it and tweak it and play around with it. So that'll be fun. Okay, so we'll start with our algorithm, which we could do in main. If I put you over here, it kind of works. Can I make you bigger? No. Cool. So step one, creator-based population. So that's going to be this type of stuff. So our chromosome size. Okay, so let's just set this to be let's just set our answer to be like oh, I think actually we set this as a hard-coded thing, didn't we? We'll do my favorite password that I use all the time. Keyboard cat. I use this in all the tutorials, everything else, for like, you know, the database and everything. Okay, so we have keyboard cat. Our chromosome size is going to be the length of this. So okay. Our population size. Sure, we'll set this to 10 and then we can tweak that. We need our base population. So that's where we need to create a population over in the library. Okay, if I want to create a population, I just want to hand it a size, right? So let's go up here, function, create population. I guess we'll have the size, which will be a, sure, usize is fine. This will be a vec of string, and then we'll just do a for in size. Let mute population. Does the alphanumeric from RAND generate white spaces? If not, then the space in keyboard cat will never be guessed. I don't remember. I think it does, but we can change it around to not have keyboard cat like that. We can probably look it up too. Let's see, letters and numbers. You're right. I don't think it does. It's just A through Z, and 0 through 9. Okay, so before I forget, there. I mean, yeah, that'd be a way to do it too. Okay, so I want create population. The population equals that 4 underscore in size. Oh, it's gonna be 2 size. I want to population and push create chromosome with the size. Okay, so we want the chromosome size, which is going to be a, what are you taking? A U size? Then we'll turn the population. Okay, so that should allow me to test now. So let's do let population equals create population of size. Okay, so size, the population size, that's going to be like, let's say 10, and let's say they're 8 each. So then I should be able to assert equal population length is equal to, that should be 10 of you. And then I should also assert equal population of 0 dot length should be 8. Okay, so I save that. Let's do a normal test again, and okay, should create a population. That passed. Okay, so I can now head back over to main so we can create a population. Okay, create a population. We're gonna have the population size. So population size, and then the chromosome size. Okay, so that gives us our population. Now we want our answers. And then, well, there's no answers. Okay, so oh, and you need to be mutable. Okay, so while answers is empty, okay, so create the next generation, and so the generation thing is this thing up here. So how do am I gonna be able to test this properly? Like this generation one seems a little bit harder for me to figure out how to test it. I guess we can just test it with that, like the sizes are still the same going in and out. And that they're not exactly the same. That's the only thing I can think of. So should oh, what is population 0 length? So that will be the chromosomes, so the individual's length. And so since individuals in this case are just strings, that it's just checking to make sure that each chromosome size is what I'm expecting it to be. So that these two things I'm passing in are being taken into account. Like, so should generation work? I don't have a good name for this. I'm not convinced that this is a good automated test. So when we're in generation, we want to select a population. Yeah, and the generation should mutate the population too. That's the other thing, is it's going to mutate here. When you create a chromosome, you use create chromosome answer length so that the length is always the same. Pointless to check a different length. I guess like in this case, this is the test just to make sure that the create population, I didn't do something wacky with it. So now in the future, when I do it for real, I can just do answer that length on it and it should work. So what are you doing? You are first, we do the selection. Now we have the selection, right? Yeah, so we do the selection. And that cuts it in half. So I guess I'm just going to write the one first, and we can figure out how to test this. So we have our generation. That's going to take in a population, which is, we know, a vec of string. And we're going to return a vec of string. So the first thing we do is cut that in half. So let survivors equals selection. Oh yeah, so we have our non-graded retain percent. Did I leave that up here? I don't have like a static or something for that. Okay, interesting. I should pass this in as things I can tweak. So as graded retain percent, non-graded retain percent. Okay, so you're the chromosomes themselves. So that's going to be this population, which I need to make mutable. So you're going to be the population. Then we have the graded retain percent, the non-graded retain percent. Oh, and I need the answer too. Okay, so that gives me the survivors. Oh, and I'm running out of time. It's almost 4:30. Okay, so then we're gonna loop through. Okay, so while the children, now you're doing, okay, return to select plus the children, because I want to keep the ones that are selected. Okay, so that makes sense. So I need to do the same thing here. So we're going to do while, oh, we need a let mute children new vector. Okay, so while the children while the children.length plus the survivors.length, well, that is less than the population.length. So that way I don't grow. I want to do our crossover. So I need to get the two parents. So we need our at RNG. We need to do a choice, right? So we're gonna have our let parent 1 is going to equal to RNG. Is it gen? Is there a sample? Oh, there's a sample. Sample uniform. And this will be the survivors. Except I don't want to give it ownership of the survivors, just a reference. Right? Will that work? Oh, just RNG? Won't RNG give me sample? Oh, did I forget to pass in? Can I initialize a tuple struct which contains... Oh, that's not what I wanted. What were you saying? I could just do RNG. Oh, sample doesn't give you double. It will remove it from there. Oh, I don't want to do that. Yeah. So, let's see. I guess I could just get the index, right? I could just get the index of that. So we could just do, okay, let's do this. I'll use the trait slice random and then the survivors choose RNG. Oh, I keep on forgetting. Do I have that slice random? I do have slice random. Okay. You told me about this last time and I forgot that it existed. So we can do our survivors. What was it? Choose? Choose. Okay, so then choose mute RNG. You should always have it, of course. I know you don't know what that is yet. That's okay. Okay, so now we have two parents. Now I want to cross over the parents and create the child. So child equals parent crossover. We have parent 1 and parent 2. Ooh, wait, did I do that right? Cannot find, parent 1. Okay, so now we have a child. mutation. Now they're suggesting they suggested that you don't always mutate the child, but rather you have a tiny probability. So let's do if RNG dot, is it gen or is it like rand? What was it? It was like random. This gives me a number between 0 and 1, right? Don't use the random on mutate. What do you mean? Any weird creatures? Nope, no weird creatures yet. Just not working yet. But like, which thing random? Are you talking about the survivors random? Are you talking about the child random? Are you talking about RNG random? Like, which thing are you talking about random or mutate? So let's see. We have then child random crossover. We cross over. Then we're gonna do our RNG. I guess we'll do a gen of an F32, which I think this will generate between 0 and 1, right? I think so. I don't remember anymore. So let's see. If that is less than 0.1, then what was the mutation? So mutate returns a string. Okay, so we're going to hand it the child. Actually, oh. Okay, I'm going to reassign the child and then redo that. With mutate on all the children, um, 8,035 total execution time. Oh, so mutate. So you just did mutate for everything. Okay, I could try that. So let's just mutate everything. Then we add. Okay, so then we finally add. So children. We push child into here. You get in there. And then we're going to return the survivors. And is there an append? Use all the elements of others. I think so. Into with children. Expect to struck vec string found. Wait, what? Oh, wait. What does this do? Append. Oh, never mind. We just do that. And then return survivors. I probably could have done concat too. Consider borrowing mute here. Maybe I should do concat. Concat the other, and then that returns, right? Concat item with self. Oh, right. That's that weird thing. Oh, extend, that's what it was. Extend. There we go. Survivors is not mutable. Okay, so then we return survivors. Okay, okay. So then I have no idea how to do the test, so we're just gonna... I'm gonna ignore that for right now because I'm not sure how to test that properly. Maybe we'll come back next time, but I'm over time right now, but I really want to try this. Am I converting the Python examples to Rust? Yeah, that's what I'm trying to do. Okay, so while the answers is empty, we generate a new population. So we're going to do let our population is equal to, okay, so we're going to do our generation. All right, so we have our population is going to need to be mutable. Population. Oh, is that what you're suggesting? Not to have the population be mutable? Because I could clone it inside of there. That would probably be better. I kind of like that more. It's like, I want to not have you... Instead of you, we're just going to do... I mean, I am taking ownership of you. Yeah, I think this should be fine. Okay. I'll just make you mutable. Yeah, we need the main. Okay, so we're creating a new population anyway, so it's being recreated and killed constantly, which is fine. Everything's fine. Okay, so graded retain percent. So that graded retain percent. We're doing 0.3. Non-graded retain percent equals 0.2. Okay, so this is our graded retain percent, our non-graded retain percent, and then the answer. Okay. All right, what are you upset about? Type annotations. You'll figure it out. Don't worry, we'll be there. Okay, so we have our population. Oh, yeah, I need to not do this. I need to not lose the population at the end of the loop. So I need to be constantly updating this population. Okay, I'm not going to print. I could print the average scores. I don't have an average scores. So let's just try. We're going to try blindly running it because I am out of time. So what we can do is just print out maybe the top one of each, like not top, just like a random one of the population. So we'll just say, we'll debug. The scores, that would be score of first individual. And that's going to be get score. Yeah, get score. We have oh, come on. I know it's okay. Fine. You're gonna be just want Rust Analyzer to help me out. Okay, so what are you? Why are you still so upset? Why don't you tell me what this is? Get score. I think it was the this will be what, like population of 0. Give me that one, and then also give me the answer. Ooh, unused result. Unwrap. Because we are doing that a lot today. That's fine. What answers vector? I am doing that here. Like, it apparently thinks that I might get multiple individuals that get the answer correctly, which is interesting. So then we check to see if a solution has been found. So do I have an answer? I don't think I do. So if, oh, so we have to do like, okay, for individual in population, if do we have an answer? No, we do not have an answer. So what we want to do is we want to say if individual is equal to answer, then answers push individual. Oh, and we'll just 2-undo. That'll be fine. Can't do that. We have a string with a stir. So instead of that, we'll do aster. Okay, so then we put that out there, and then down here we're going to just debug. I guess in this case we can print line. So print line, we found the answer. And we can do answers. Sure, let's just debug and take a look at all of them. All right, well, you seem to be okay with this. You just need to leave, well, when the score equals 1, right? I guess like that's the other way to do. That's the other way to do it. Okay, so regardless of the outcome of this result, this is gonna have to be it. So either this is gonna crash, it's gonna take my system down, or it's going to or it's gonna work, or it's gonna take forever. Either way, we're gonna find out how it goes. So it's cargo. I guess let me connect this first and push it up. So this is attempt 1 at, well, I guess like ported like solution over question mark. I'm very like strongly feeling about that. Cargo run. Hey, okay, it found the answer. Excellent. That was much better than a Python one. Wow, my scroll jumped up quite a bit. And you can see the first individual getting closer and closer. Okay, that's not bad. So it worked, yes. Okay. Try to mutate with 1%. I need to remember what does the mutation work on mutate would mean that it takes longer, right? So is, okay, so the question is a random number, is an F32, it's like random chance to mutate. Mutate chance. If I do gen, oh, you just do, okay, I could actually do that. I could do random gen range between 0 and 1,000. That's not how to do ranges. And okay, 1,000. And then if mutate chance is less than, I guess is equal dot is less than or equal to 1, then mutate the child. Otherwise, leave the child alone. So if I do that, the other thing that I want to do is I want to count how many generations. So let mute generations is equal to technically 1 at this point in time. I want score of each individual is less let's then down here we'll do generations plus 1,897 generations. If chance is less than 1, mutate the child. Otherwise, just leave the child alone. Yeah, exactly. Like half the time working with any of these things is generally out of context, or, you know, not great clip material, because it's like we're constantly like, okay, we're going to take half the children, half our population, and just kill them and force the rest to cross over to have children with the remaining ones, repopulate, and then put them all through the ringer again. Yeah, so it doesn't really look that great. Now if I got like the average here and like started looking through that would be really interesting. But hey, this is great. This is working. Let me go ahead and commit this. Working. Oh, right. Double quote on after a exclamation point. Okay, let's try this again. Commit. Working. Do I have to? No, I'm just going to do that. Okay, push that. If any of you are interested in the Rust code for this, I have that here. So you can see our new working in the source. There's a link to the tutorial that we followed, which was perfectly fine up until the very end, in which case they pulled and do the rest of the owl, like draw the rest of the owl on us. But it was okay. We figured it out. Thank you everybody for helping out with that. I unfortunately have to do an emergency stream shutdown. I need to go grab some dinner really quickly before another meeting that I have later today. And then tomorrow morning I'll be back for more U code. And then tomorrow afternoon I want to continue learning with this, but we're off tutorial land. Now we're going to be climbing up the Bloom's taxonomy on our own. I'll probably explain Bloom's taxonomy too, because I've been using that and not talking about what I'm talking about. So anyways, thank you everybody and have a great rest of your day. Bye.